Hello and welcome to the new video series about ordinary differential equations. This will be a video series for everyone who is interested in the theory of differential equations and how to solve them. So essentially, it's a mathematics course, but it's also important for a lot of other science subjects where differential equations occur. Therefore, you might have already seen a differential equation. For example, f prime is equal to f is a common one. Roughly speaking, this equation means that we search for a function f that is differentiable and fulfills this equation. More precisely, here it means that the derivative of the function f is equal to the function itself. And then you might already find that the exponential function does the job. So f of x is equal to e to the power x solves this differential equation. Okay, at this point I would say a lot of questions immediately occur. First, how can we solve such an equation if we don't have any idea what the solution could be? Second, in the case that we find a solution, what can we say about the uniqueness of this solution? Moreover, besides the existence and uniqueness of solutions, you could also ask small questions like, what is the domain of definition for a solution here, and can it be different for different solutions? Indeed, all these questions and many more we will answer in this video course here. And a good starting point would be to talk about the prerequisites you need to understand all the videos here. However, before we do that, I really want to thank all the nice people who support me on Steady via PayPal or by other means. This freely available video course only exists because nice people support the production of it. And indeed, as a supporter, you get rewards like quizzes and PDF versions for all the videos. To find them, just click the link in the description. Okay, now let's talk about the requirement, the knowledge you need to understand ordinary differential equations. In fact, there are two main ingredients here. On the one side, you need to know what derivatives are, so you need the real analysis part, and then you need to calculate with vectors, so you need the linear algebra part. For both topics I have video courses where you can watch the relevant parts. However, if you're very new to mathematics, I would like to suggest that you first watch my Start Learning Mathematics course. There I tell you about typical notations, what numbers are, what sets are, so all the foundations you need to understand the rest here. Okay, so now you know what we need, and you see we don't need a lot of multivariable calculus simply because we will not talk about partial differential equations. So we will not consider partial derivatives in the equations, just ordinary derivatives. Indeed, this makes the whole topic much easier to deal with. However, in order to motivate you why ordinary differential equations are still interesting and very important, let's look at some other examples. So for example, you might know that in physics one uses dots for denoting the time derivative. Hence, this here is the second derivative of the function x of t. And now this should be equal to omega squared x. Indeed, in physics, this equation here describes a so-called harmonic oscillator. And depending how much you want to calculate with complex numbers, you have a minus sign here or not. And there I should tell you, if you don't know complex numbers, you should check out my Start Learning Mathematics series. However, in the end here, complex numbers will only be important for some calculations. Okay, so now we can consider another example, also given by physics. Indeed, this one is easy to explain. You just have three planets here and they will interact with gravity. So simply said, they will attract each other. And now, if you describe the one planet in 3 dimensions with a vector x, and the next one with a vector y, and the third one with a vector z, then we can use Newton's gravity. So the mass m times x, second derivative, is equal to the gravity force. However, this force F now is a function that depends on all the positions here. Hence, the equations for the different planets here are connected by this force. So you see, indeed, we have 9 differential equations that are completely cross-linked here. Hence, we would say we have a whole system of differential equations, and we want to solve the whole system. Moreover, you see here, in contrast to the first example, we have second order derivatives here. However, we will see that for the theory of ordinary differential equations, the order of the derivatives is not so important. Okay, and this brings me to a short overview what we will do in this course. So the first thing I already told you, we will talk about systems of differential equations. Moreover, in the future, we will abbreviate ordinary differential equation simply by ODE. Okay, then after this abstract theory, we will talk about some practical solution methods. So we will look at the procedure, how to solve such a system of ordinary differential equations. And then we will go back to the theory again and prove the existence and uniqueness of solutions. In particular, we will see what are the correct assumptions we need to have uniqueness. And then, in the end, we will also talk about linear ordinary differential equations. There, the so-called matrix exponential function will play a crucial role. So this is the plan for this course, and I would say let's start with the important definitions in the next video. Therefore, let's meet there and have a nice day. Bye!